I bet you didn't know how much goes into building a skyscraper. Ever looked up at a skyscraper and wondered, how in the world does that thing stand up? It's a question that's crossed my mind a time or two after gaining extensive field experience. Take the Eiffel Tower, for example. This iconic symbol of France isn't just a pretty face, it's a masterpiece of engineering designed to sway slightly in the wind. That's right, you heard me correctly. The Eiffel Tower, all 1,063 feet of it, is designed to move. It can sway as much as 7 inches in strong winds. This isn't a flaw, it's a feature, a testament to the ingenuity of structural engineers. These are the men and women who make sure our buildings don't just stand up but can withstand the test of time and Mother Nature. We're talking about the science of keeping things upright, the art of turning steel and concrete into gravity-defying wonders. And trust me, it's a lot more fascinating than it sounds. So, let's roll up our sleeves and get our hands dirty with the fascinating world of structural engineering. Now, when you think of construction, you might picture hard hats, cranes, and maybe a few well-placed explosions. But behind every impressive structure is a team of dedicated engineers, the often unsung heroes who turn blueprints into reality. These are the folks who sweat the small stuff, calculating loads, stresses, and strains, making sure every beam and bolt is in its rightful place. They're like the conductors of an orchestra, making sure each instrument, or in this case, each building material, plays its part in perfect harmony. And believe me, the stakes are high. It's not just about aesthetics, it's about safety. The weight of a building, the force of the wind, the tremors of an earthquake. These are all factors that structural engineers juggle daily. They use their knowledge of physics, math, and material science to create structures that can withstand incredible forces. They're the guardians of our built environment, ensuring that our homes, schools, and workplaces are safe havens, not potential hazards. We've all seen the devastating effects of natural disasters. Hurricanes ripping through coastal towns, earthquakes reducing buildings to rubble. These events are a stark reminder of the power of Mother Nature and the challenges faced by structural engineers. Wind, water, seismic activity, these are just a few of the forces that can wreak havoc on structures. That's why engineers spend countless hours analyzing weather patterns, studying soil conditions, and designing structures that can withstand these extreme events. It's a constant battle against the elements, a test of ingenuity and resilience. But it's a battle that engineers are determined to win. Because at the end of the day, it's about protecting lives and creating structures that stand the test of time, no matter what Mother Nature throws our way. Section 4. Secrets from a construction site, building to last. Now, you don't need to be a structural engineer to appreciate the importance of a strong foundation. It's the bedrock, the unsung hero that supports everything above it. And just like a house needs a solid foundation, so too do our bridges, skyscrapers, and even our roads. Think of it like this. You wouldn't build a house on sand, would you? The same principle applies to larger structures. The ground beneath our feet isn't always stable. Engineers use a variety of techniques to ensure stability, from deep foundations that reach bedrock to innovative materials that adapt to shifting soil conditions. It's all about working with nature, not against it. And it's a testament to the ingenuity of engineers who find ways to build on even the most challenging terrains. Section 5. A bridge to remember when engineering matters most. Let me tell you a story about a bridge. Not just any bridge, but one that holds a special place in my heart, and in the annals of engineering marvels, the Golden Gate Bridge. This iconic bridge, spanning the San Francisco Bay, is a testament to human ingenuity and the power of structural engineering. But the Golden Gate story isn't just about steel and concrete, it's about the people who built it, the workers who risked their lives, suspended hundreds of feet above the water, to connect two shores. It's about the engineers who battled relentless winds, treacherous currents, and even the occasional earthquake, to create a structure that has stood for generations. The Golden Gate Bridge is a symbol of what's possible when we combine human ingenuity with a deep respect for the forces of nature. It's a reminder that engineering isn't just about numbers and calculations, but about connecting people, places, and dreams. Section 6. The future of building stronger, smarter, higher. So, where do we go from here? What does the future hold for the world of structural engineering? Well, let me tell you, things are about to get even more exciting. We're talking about buildings that can adapt to earthquakes, bridges that monitor their own health, and materials that are stronger and lighter than ever before. Imagine a world where skyscrapers sway gently in the wind, absorbing its energy instead of resisting it. Picture bridges that can tell us when they need repair, long before a crack becomes a catastrophe. That's the future of building, and it's closer than you might think. We're on the cusp of a new era in construction, one where sustainability, resilience, and innovation go hand in hand. And I, for one, can't wait to see what incredible structures we build next. What do you think? What amazing feats of engineering do you hope to see in your lifetime? Share your thoughts in the comments below.